Am I audible? Yes, I am going to take the two parallel meeting for section A and section B. Okay. So from both the sections, I want a response whether I am audible or not. In meanwhile, if you are having any problem, please give me the message through chat box. Okay. And one thing, every day section A will join through Google Classroom link, and section B will join the link which I will send every day before 10 minutes. Okay. Section B students, don't join with the Google Classroom link. Okay. Because I have to mark separate attendance, section A and section B. Okay. So today I'm going to just take this meet parallel, and I'm just going to take trial. Okay. If you are having any problem, please tell me. Okay. Now I'm going to start the uh, class. So I presented the screen. Is it visible to all of you? Yes. So I'm going to start the next unit, unit number 5, that is a moment distribution method. So in this unit, you have to study about the frame analysis, portal frame we are going to study, and we are going to analyze the indeterminate structures. So initially before this, we have studied about the indeterminate structures. So you know about the indeterminate structures. So here in this unit, we are going for the analysis of frame, which will be the sway analysis. And in essay 1, you have studied about the moment distribution method, and you are very much familiar with this method. You know this method and how to analyze a structure that you know. You have done the analysis of beam and frame. But that in case of frame, you have studied about the non-sway analysis. Okay. You have considered the non-sway frame for the analysis. But here the change is that in this subject, and particularly in this unit, we have to study about the sway analysis. Okay. So the frame we are going to consider, that will be of sway frame. So before to proceed for the analysis and for the problems, I will give you the introduction about this method, and again I will tell you about that how the analysis of such frames will be carried out. Such frames means sway frame. Okay, so you should know about the basic difference between the non-sway frame and sway frame. Okay, the non-sway, sway means displacement, deflection of the frame. Okay, So if the frame will be deflected by an amount of delta, if there is an force is acting in the lateral direction, there may be the deflection in the frame. That may be the that may be a horizontal load, like it may be wind load or the earthquake load. So due to that, the frame will get deflected. Okay, so that deflections we have to consider for the analysis, but and that will be possible only in case of if the frame is sway frame. So how we can say that the frame is a sway frame? Sway means displacement. So first of all, I will tell you about the non-sway frame. Non-sway means no deflection, no displacement at the end of the member. Okay, so when we can say that frame is a non-sway frame, so your non-sway or displacement will be possible with the various conditions, like it will be based on the geometric conditions of your frame, it will be based on the end conditions of your frame, material property will also is will be there. Okay, and again at the beam level, if there is a support at the beam level, the frame will be prevented from sway. That is called as a non-sway frame. And if the load is acting on beam or column member, if it is acting exactly at the center, and if the end conditions are same, if it is a fixed support or like that, and the length of the column, if it is same, material property is same, geometry is same, and if the support is provided at the beam level, then we can say that the frame it is a non-sway frame. And you have done the analysis of such frames in SA1. So in that analysis, you have calculated the non-sway moment, which you have called it as a my final moment. Okay, but practically if we'll see, no frame will be a non-sway frame. There will be some sway, there will be some deflection in the frame. Okay, but when we are going to study any type of the method, the part is that first of all you should analysis non-sway frame, and then when we are going for the sway frame. So in sway analysis, we are going to perform the analysis in two ways. Okay, and how it is to be performed, that we will see. So sway frame means if there is a deflection at the end of the columns due to the load applied at the in the horizontal direction, if the load is not exactly at the center of your members, and if the geometric condition is not same, material property is same like E and I value, and if the end conditions is different, okay, and length of column is different, and if there is a horizontal load is acting at the node, the frame we can say it is a sway frame. Okay, so that analysis we are going to perform in this unit, okay, with the help of the moment distribution method. So this also we can say that this moment distribution method, it is a displacement method, and we are going to analyze only the sway frame, okay, which is of indeterminate structures. Okay, so I'll just go with the introduction part. So this you know the method and you know the process of the moment distribution method. Just there is a inclusion of one extra step for the sway analysis. Okay, so this method is useful for the analyzing of beam and frame. Only in this unit we are going to study the analysis of frame. It is developed by Hardy Cross in 1930. It is a basically a displacement method of analysis. Okay, so but this method sidesteps the calculation of the displacement and instead makes it possible to apply a series of converging corrections that allow direct calculations of the end moment. We are finding out the end moments using this moment distribution method. Okay, or we can say it is a joint to joint method. Okay, this method consists of solving slope deflection equations by successive approximation that may be carried out to any desired degree of accuracy. Okay, then here I have just explained the process of this method. Essentially, the method begins by assuming each joint of structure is fixed. Then by unlocking and locking each joint in succession, the internal moments at the joints are distributed and balanced until the joints have rotated to their final or nearly final position. So when we are going to see the problems, we know the method, we know the steps, how the joint is to be balanced and how the movement is to be carried out, and if it is a hinge support, if it is a fixed support, and accordingly we are finding out the final positions, means we are finding out the final moment. Okay, this method of analysis is both repetitive and easy to apply. Okay, before explaining the moment distribution method, I will explain here the analysis of sway frames. Okay, certain definitions and concepts must be understood. So, as you know that the sign conventions, we are considering the clockwise moments will be treated as positive and anti-clockwise moment will be treated as negative. This sign convention generally we are using, but for drawing bending movements causing concavity upward sagging will be treated as positive, and moment causing convexity upwards, that is hogging, we will be treated as negative. Okay, and again while analyzing any structure using this method, you should know the fixed end moment. Okay, so there here I have listed some fixed end moment. You know the definition of fixed end moment. The moment at the fixed joints of loaded member are called the fixed end moment. So you have some cases where you should know the fixed end moment of that case. For some few standard cases, if the load is acting exactly at the center, if the load is not at the center, if there is a uniformly distributed load, if there is a varying load. Okay, so because when we are going to solve the problems of frame or beam, there may be the any type of the loading. Okay, so every time whenever we are going to carry out the analysis of any structure using this method, first step is always to find out the fixed end moment of your members. Okay, and that depends upon the which type of the loading is acting on your structure. So here some few standard cases I have given the fixed end moment, and you are very much familiar with this, you know this. Okay, only you have to learn this. Okay, to find out the fixed end moment of any member. So here you can see that load is exactly at the center. So fixed end moment AB anti-clockwise and fixed end moment BA is clockwise. So here anti-clockwise we are considering minus and clockwise we are considering plus. So this is minus WL by 8 plus WL by 8. Okay, so some few cases I have listed here. Here you can see that load is not acting at the center. So fixed end moment AB is WAB square by L square and WA square B by L square. If there is a 2 load at the center, you can use this formula. Okay, 2PL by 9 minus, and this is plus 2PL by 9. Okay, or you can go with fixed end moment AB WA square WAB square by L square plus WAB square by L square, and fixed end moment BA WA square B by L square plus WA square B by L square, like that you can do it. Or if there is a uniformly distributed load, you can see it is WL square by 12, WL square by 12. Okay, minus plus. Then there may be this type of the loading also on your structure, uniformly varying load. Okay, so this end moment, fixed end moment is minus WL square by 20, and fixed end moment BA WL square by 30. Okay, and for the last case, this is also the uniformly varying load. Okay, so here you can see the fixed end moment AB is 5 WL square by 96, and fixed end moment BA, it is plus and AB is minus. Okay, so these are the some of the cases you have to keep in mind for the for finding out the fixed end moment. So generally there will be point load, there will be the uniformly distributed load, there will be the uniformly varying load also, and also there will be the moment at the end A, or at the center also. Okay, that I have not included here. Okay, but you can search it from any book, or you can search it from net, and you just write down that if there is a moment, clockwise moment hai, A or B, or anti-clockwise movement hai, then what will be the fixed end movement AB and fixed end movement BA. Okay, so then this just I am going to repeat these things because already you know this method and you know about the distribution factor and the stiffness factor. So I'll not I'll not focus more on this. Okay, just I will tell you that how the distribution factor is to be calculated and how the stiffness factor is to be calculated. Okay, because this distribution factor is based on the your relative stiffness factor. Okay, so this distribution factor for any member is the ratio of stiffness of that member to the sum of the stiffnesses of all the member meeting at that joint. Okay, so this is we are considering to calculate the distribution factors. We are considering the joints, and at the joints how many members are connected that to join. We are just adding that, we'll get the summation K. So this K in general, the distribution factor, it is equal to K by summation K. So this formula you have to keep in mind, that is K by summation K. Okay, so K is the relative stiffness of that particular member, and summation K, it is the sum of the stiffness of all the member meeting at that joint. Okay, whatever the how many members will be connected to that joint, you will just add the stiffness, so that will gives you the value of summation K. तो ये फॉर्मूला भी आपको ध्यान में रखना है, K by summation K, and distribution factor addition of this is always equal to 1. Okay, then a relative stiffness factor, it is denoted by K. Okay, so in majority of the cases, continuous beams and frames will be made from the same material, so that their modulus of elasticity, sorry, यहाँ पे electricity लिखा, modulus of elasticity E will be same for all the members. Okay, so ये भी आपको ध्यान में रखना है कि if the end of the member is fixed, K can be calculated as I by L. Okay, it is calculated by I and divided by L, that is I is the moment of inertia, and if for far end is hinge or roller supported, okay, or ये this is for continuous and for fixed end, that K will be considered as I by L, and for hinge end roller supported, suppose that K will be considered as 3 by 4 into I by L. Okay, so ये दो formulas आपको ध्यान में रखना है to calculate the relative stiffness factors, which is denoted by K. Okay, once you get this value of K, then you can find out the distribution factor. Okay, So these are the terms we are going to use in this moment distribution process. Then the next is I will start uh, actual the sway analysis of frame. Okay, we are going to study about the frames with side sway. Okay, side sway means you can see that in this figure 1a, you can see the side sway. This we can say that a side sway. Okay, so already I told you about the what exactly the sway frame. So you just try and understand about the sway frame. You just try and understand about the sway frame. So what exactly the sway frame? It is sway frame, or we can say it is a side sway. So how this moment distribution method is applied for frames with side sway, that analysis how it is to be carried out, that we will see one by one. First of all, you just understand the meaning of the sway frame. So here you can see that frames that are not symmetrical with reference to material property or geometry, like the different lengths and the I values of the column. Okay, if the I values is different and the length is different, material property is also different, and which is non-symmetrical, okay, which is not symmetrical, or support conditions are not same, length is different, or subjected to non-symmetrical loading. Okay, means loading will not exactly at the center of your member. Okay, so these are all the uh, properties we can say that will make the frame as a sway frame. Okay, length different रहेगी, I values of column can be different, support conditions also different, or the main thing is that if the loading is subjected to the non-symmetric loading, which is having a tendency to side sway. Okay, so that is called as a sway frame. Okay, so this example I have given here, you can see this figure. So an example has been shown in this figure. So in this figure, in first figure 1a, you can see that the frame is there where the end conditions are same. Okay, column length are same, but you can see here this load P load is not symmetric load. Is not symmetric load. We can say that like this P is acting from B is 1 meter and from C it is 3 meter. It is not exactly the symmetric force. So that also will be the responsible factor for the frame will get have a sway. So there will be a sway as the load is, there may be the vertical loading also, or there may be the horizontal loading also. Okay, so that also is responsible for your frame. Okay, so you can see this force P, it is not symmetric. So due to that unsymmetric loading, okay, there will be a chances of sway frame. Okay, it can be like that, or your frame, if the frame is like this, okay, and if the loading is acting in the horizontal direction, then this will be the one of the reason that your frame will get deflected like this. The frame will get deflected like this. Okay, so and length of the column is, but here we whatever the example I have considered here, the end conditions are same, but loading is unsymmetric loading. So you can see that this will be your the actual frame. This is actual frame, and this is the deflection will be there due to the unsymmetric loading, and this displacement we have considered as the displacement delta. Okay, and this frame will get deflected, this column AB will get deflected like this. Okay, as this support is fixed support, so there will be the deflection like this. Okay, so this is your actual frame. This is actual frame is shown here. Okay, and this is due to this unsymmetric loading. Your frame will get deflected by an amount of delta. Okay, so how this sway frame will be the analysis is to be carried out, that we will see. So first of all, you should understand the concept, how it is to be solved. So analysis of such frame will be carried out in two ways. In both two ways, the analysis is to be carried out. Okay. The first, this actual frame will get divided into the two frame. Okay. The first analysis will be carried out as a non-sway analysis, and second analysis will be carried out as a sway analysis. Okay, so first of all, I will explain you about the analysis, how it is to be carried out, and then I will move to this figure, how it is to be divided into the two parts. Okay, so we can see that the analysis of such frames, which such frames mean sway frame. जो भी अपन analysis इसमें carried out करेंगे, particularly in this unit, we are going to carry out only the frame analysis, and only we are considering the sway frame. We are not considering the non-sway frame, because non-sway frame analysis is very simple. What extra we have to learn in this subject? We have to analyze the sway frame using this method. Okay, so analysis of such frame will be carried out in the following steps. Okay, just try and understand the steps. Okay, so first, step 1, first the frame is considered, as prevented from side sway by applying an artificial support at C as shown in figure 1b. You can see this figure. Okay, you can see this figure. First, the frame is prevented from side sway. Okay, whatever the actual frame will be given to you, that will be your sway frame. Okay, but and the external loading will act on that frame. Okay, but as we have to analyze this frame as a sway frame, okay, first of all you have to carry out the non-sway analysis, then you have to carry out the sway analysis. तो final moment जो आपको मिलेगा, that will be your non-sway moment plus sway moment, and that sway moment we are applying a correction factor, because non-sway analysis is carried out only for the external loading. Okay, जो भी frame पे external load act हो रहा है, only for that the non-sway analysis is to be carried out. But sway means displacement. How much displacement we are assuming? We are assuming delta. We are assuming delta, and both this effect will not be considered together. We cannot consider the external loading plus displacement together. So in what way it is to be analyzed? First, we are considering the actual frame as a non-sway frame. Then how we will consider it? Because frame is a sway frame. Frame is sway frame. So as you can see here, this is actual frame. This is actual frame. So this actual frame is to be divided into two parts. So your first frame will become a non-sway frame. First frame will be non-sway frame, but actually the frame is sway frame. Okay, but when it will become a non-sway frame, because we have to prevent this frame from sway. Matlab, first we will consider the frame, okay, as a non-sway frame by providing the artificial support at this level. Okay, will provide the artificial support at C. Okay, so as you know that non-sway frame means if there is a artificial support at the beam level. If there is a support at the beam level, the frame is called as a non-sway frame. Okay, so as the frame is a sway frame, okay, first of all we have to go for the non-sway analysis. So actual frame will have to consider it as a non-sway frame. So how we will consider it as a non-sway frame? By applying the artificial support at C shown in figure 1b. If we provide this artificial support at C, the frame will be prevented from sway. There will be no sway in this frame. Okay, there will be no sway in this frame. Your frame will be prevented as a sway. Okay, so that is called as a non-sway frame. Why we are doing this? Because whatever the external loading on you acting on your structure, this external loading से fixed end moment आएगा frame पे, और ये जो displacement हो रहा है इसकी वजह से भी frame पे या column पे moment आएगा, which is 6 या delta by square. So external loading moment plus delta की वजह से sway की वजह से जो moment developed होंगे, that we cannot consider togetherly. इसीलिए इस एक्चुअल फ्रेम को अपन दो फ्रेम में डिवाइड करते हैं. पहले वी आर गोइंग टू मेक दिस फ्रेम एज अ नॉन स्वे फ्रेम बाय प्रोवाइडिंग द आर्टिफिशियल सपोर्ट एट सी. मतलब अपन ने डिफ्लेक्शन को प्रिवेंट कर दिया है, तो डेल्टा इसमें नहीं आएगा. तो ओनली ये जो एक्सटर्नल लोडिंग आपके मेंबर पे एक्ट हो रहे, अभी यहाँ पे बीम पे है, देयर मे बी लोडिंग ऑन द कॉलम आल्सो. ओके, तो ये एक्सटर्नल लोडिंग से जो फिक्स्ड एंड मूवमेंट डेवलप्ड होंगे, वो फिक्स्ड एंड मूवमेंट को कंसीडर करके अपन उसका एनालिसिस करेंगे. उसको बोलते हैं नॉन स्वे एनालिसिस. मींस इन द नॉन स्वे एनालिसिस ओनली द एक्सटर्नल लोडिंग इज कंसिडर्ड. Okay, only loading effect is considered, no displacement is considered. Okay, so ये नॉन स्वे फ्रेम हो गई, उसका नॉन स्वे एनालिसिस करेंगे. Okay, plus then as we are providing the artificial support here, the retaining force will be developed here. Retaining force will be developed in the horizontal direction. Okay, okay, that is called as a unbalanced non-sway force, or we can say it is a non-sway force. यहाँ पे artificial support provide करने की वजह से यहाँ पे retaining force developed होगा. ये retaining force क्या करेगा? This force will prevent this frame from sway. Okay, so this retaining force you have to find out by using the entire equilibrium of the frame that we will see. But as this force is developed here, same force will be developed at end B, but will be in a opposite direction. Same force रहेगा, that is called as a sway force. Okay, I have just denoted this force as S dash and this force is S. Again, I have shown that figure after this. So due to this force will be developed at B, equal in magnitude but opposite in direction, and due to this force the frame will get deflected by an amount of delta. Okay, so this will become your sway frame. This will be your sway frame. Okay, so analysis of this frame will be carried out by considering this displacement effect. So the thing is that whatever the actual frame is given to you, that frame is going to be divided into two parts. First will be your non-sway frame. Second will be your sway frame. Okay, so just you should see here in the step 1. First, the frame is considered as prevented from side sway by applying an artificial support at C. Okay, why we are providing the artificial support, that I told you now, because we have to prevent the swing. Because सिर्फ अपने को लोडिंग इफेक्ट के लिए एनालिसिस करना है, उसको बोलते हैं नॉन स्वे एनालिसिस। तो फ्रेम को अपने को नॉन स्वे फ्रेम बनाना है, इसीलिए अपने वहां पे अपन ने एक सपोर्ट प्रोवाइड किया है। देन द मोमेंट डिस्ट्रीब्यूशन इज कैरिड आउट फॉर एक्सटर्नल लोडिंग similar to non-sway frame as you have done in SA1, okay, called as a non-sway analysis, same as a non-sway frame। उसको अपन ने non-sway frame बना दिया एक सपोर्ट प्रोवाइड करके, तो आपको वैसे कैरी आउट करना है। कैसे कैरी आउट करोगे? स्टेप 1 होंगी फिक्स्ड एंड मूवमेंट, स्टेप 2 होंगी डिस्ट्रीब्यूशन फैक्टर, फिर अपन थर्ड स्टेप होंगी नॉन स्वे मोमेंट डिस्ट्रीब्यूशन टेबल बनाएंगे, ओके, दैट और अपन नॉन स्वे मोमेंट फाइंड आउट करेंगे, ओके। सो देन बाय यूजिंग स्टैटिक्स मींस इक्विलिब्रियम कंडीशन, रिस्ट्रेनिंग फोर्स, जो मैंने आपको रिस्ट्रेनिंग फोर्स आपको यहाँ पे बताया है, as we are providing the artificial support, this is your restraining force which is denoted by S, okay। So that restraining force, it is called as a non-sway force, so that is to be determined by considering the horizontal equilibrium of the frame, that is summation fx is equal to 0। क्योंकि सपोर्ट अपन बीम लेवल पे प्रोवाइड कर रहे हैं तो हॉरिजॉन्टल फोर्स डेवलप्ड होगा, इसीलिए कंडीशन ऑफ इक्विलिब्रियम we will use as summation fx equal to 0 for entire frame। तो at the time of taking the problem ये आपको समझ में आ जाएगा, तो वहां से अपना नॉन स्वे फोर्स निकालेंगे। उसके बाद स्टेप 2, the equal but opposite force S dash is then applied to the frame as shown in figure 1c। You can see that equal but opposite force I have denoted by S dash, okay। तो ये force apply होगा, okay, to that frame, due to that there will be the displacement की वजह से moment developed होगी। So as you know that if there is a displacement at any one end of the member, here you can see that there is a displacement at this end, okay। the moment developed at both the end of the member, it is 6CR delta by L square at both the end of the member, okay, that is minus, and there is only the displacement of the column, there is no displacement in the beam level। Why? Because both the legs are vertical leg, okay, there is no inclined leg in this, okay, so there is only the displacement in the column member, there is no displacement in the beam member, so there will be no moment will be developed in this beam, only there is a moment developed at AB and CD, fixed end moment AB, BA। So then this fixed end moment we will consider for the analysis, and we will carry out the moment distribution process, okay। So and moments in the frame are calculated using moment distribution process called as a sway analysis। उसको क्या बोलेंगे अपन? sway analysis। sway यानी डिस्प्लेसमेंट, डेल्टा की वजह से जो मोमेंट आएगा वो मोमेंट को कंसीडर करके मोमेंट डिस्ट्रीब्यूशन कैरी आउट करेंगे, अपने को फाइनल मोमेंट मिलेगा, नॉट फाइनल मोमेंट, विल गेट द स्वे मोमेंट। पहले स्टेप में नॉन स्वे फ्रेम लोडिंग को कंसीडर करके फिक्स्ड एंड मोमेंट निकालेंगे, उसको बोलेंगे नॉन स्वे एनालिसिस, और वहां से अपने को मिलेगा नॉन स्वे मोमेंट। then by using statics we will find out the sway force S dash by again considering the equilibrium of the frame, that is summation fx equal to 0, okay। So for entire frame you have to use this equation and you have to find out the sway force। उसके बाद what will be your final moment? Your final moment will become, यहाँ पे final moment will be equal to your नॉन स्वे मोमेंट प्लस k इंटू स्वे मोमेंट। ये नॉन स्वे मोमेंट जो आपको मिलेंगे ये लोड को कंसिडर करके मिलेंगे, ओनली लोडिंग इफेक्ट इज कंसिडर्ड, वी आर नॉट कंसिडरिंग बोथ द इफेक्ट साइमल्टेनियसली। लोडिंग इफेक्ट को अलग कंसिडर करना पड़ेगा, और स्वे का इफेक्ट यानी डेल्टा आर्बिट्ररी डिस्प्लेसमेंट अपने को इमेजिन करना है। आर्बिट्ररी मतलब एज्यूम डिस्प्लेसमेंट, तो ये डिस्प्लेसमेंट की वजह से जो मोमेंट आएगा कॉलम पे, उस मोमेंट को कंसीडर करके अपन स्वे एनालिसिस करेंगे तो आपको स्वे मोमेंट्स मिलेगा. प्लस this is k into sway moment. Why k? Because these are the arbitrary moment we are considering. Okay, this is assumed moment. तो जो करेक्शन फैक्टर जो अप्लाई होगा वो अप्लाई होगा k into sway moment. Okay, because this is assumed moment, you can assume it in any way. Someone will assume the value of 6EI delta equal to 100. Someone will assume the value of 6EI delta by L square is equal to 100. That will be our assumed moment. So we are applying the sway corrections to the sway moment. Then how it is this k? It is called as the sway correction factor. This k is called as the sway correction factor. So this sway correction factor, it is calculated by non-sway force divided by sway force. S by S dash. S is your non-sway force and S dash is your sway force. Okay, तो ये S और S dash कैसे मिलेगा? By using the equilibrium of your frame. And both these forces are horizontal force, so you have to use this condition, summation effect. Okay, so ये जब अपन प्रॉब्लम सॉल्व करेंगे तो आपको ये आ जाएगा. But K is what? Sway correction factor. And where this correction is to be applied? It is to be applied to the sway moment. Okay, because non-sway moment is your loading effect से वो आपका actual moment रहेगा, but sway moment आपका assumed moment है, इसीलिए correction जो apply होगा that is to be K into sway moment. So final moment जो आपको मिलेगा that will be equal to non-sway moment plus K into sway moment. Okay, इसके पहले जो आपने non-sway frame को analyze किया है उसमें आपका फाइनल मोमेंट इज नथिंग बट योर नॉन स्वे मोमेंट, क्योंकि वो आपकी नॉन स्वे फ्रेम थी. एक ओनली फॉर वन पार्ट के लिए आपने उसको एनालाइज किया है. नाउ आपको स्वे फ्रेम को एनालाइज करना है, इसीलिए उसको दो पार्ट में डिवाइड करते हैं नॉन स्वे फ्रेम प्लस स्वे फ्रेम, और उसके बाद आपको मिलेगा फाइनल मोमेंट. ओके, वंस यू गेट द फाइनल मोमेंट you will be able to draw the bending moment diagram. Okay, again here in this figure again I have shown this actual frame. Okay, you can see the type of the loading here. There may be the any type of the loading. Here I have shown it is UDL, and this load is exactly at the center, but end conditions be same hai, but length of the column is different. Okay, so again this frame will be sway frame. Okay, तो आपको सिर्फ ये ध्यान में रखना है कि what factors is will be depend for the sway frame. ठीक है, तो that may be your end condition, that may be the material property, I value change हो सकती है, unsymmetrical loading, okay, and the different length of the column. Okay, तो यहाँ पे ये एक्चुअल फ्रेम है, फिगर ए, दिस इज योर एक्चुअल फ्रेम. ओके, तो सिंपल कॉन्सेप्ट है, पहले फ्रेम को नॉन स्वे फ्रेम बना दो. हाउ वी विल मेक दिस फ्रेम एज नॉन स्वे फ्रेम? ओके, बाय प्रोवाइडिंग द आर्टिफिशियल सपोर्ट एट दिस एंड सी. यहाँ पे एक आर्टिफिशियल सपोर्ट प्रोवाइड करेंगे तो ये फ्रेम को अपन प्रिवेंट करेंगे फ्रॉम स्वे. देयर विल बी नो डिस्प्लेसमेंट इन दिस फ्रेम. एक्चुअल फ्रेम इज दिस, बट एनालिसिस करने के लिए ये एक वे है, इस वे से आपको स्वे एनालिसिस करना. तो पहले इसको नॉन स्वे फ्रेम बना दिया, वी विल कैरी आउट द नॉन स्वे. यानी ये जो लोड एक्ट हो रहा है इससे फिक्स्ड मोमेंट निकलेगा, उसको कंसिडर करेंगे और उसका नॉन स्वे. फिर ये रिस्टेनिंग फोर्स है, उसको मैंने बोला है एस, दैट इज अ नॉन स्वे फोर्स. ये रिस्टेनिंग, ये फोर्स रिस्टेन करेगा इस फ्रेम को डिफ्लेक्शन से. ठीक है, उसके बाद आपको ये एस फोर्स निकालना है, स्वे फोर्स. तो आपको पूरा इसका फ्री बॉडी डायग्राम ऑफ ए बी, फ्री बॉडी डायग्राम ऑफ सी डी, कॉलम का एफ बी डी निकाल के रिएक्शन एट द सपोर्ट्स निकालना पड़ेगा, HA1 HD1. ये आप मोमेंट कंडीशन से, इक्विलिब्रियम कंडीशन से निकाल सकते हो. वंस यू गेट दिस वैल्यू HA1 HD1, देन यू कैन यूज दिस समेशन Fx इज इक्वल टू 0. ओके, तो ये आपको, ये फ्रेम में आपको इक्वेशन मिलेगा HA1 प्लस HD1 माइनस S, ओके, इक्वल टू 0। तो आपको यहां से S की वैल्यू मिल जाएगी, ठीक है। प्लस आई हैव रिटन हियर K, तो K मीन्स करेक्शन फैक्टर, प्लस K इंटू ये फोर्स रहेगा, बट दैट विल बी K इंटू S डैश रहेगा, K इंटू S डैश, ओके। सो दिस S डैश इट इज अ स्वे फोर्स, ओके, एंड दैट विल बी एक्ट इन द अपोजिट डैश, यानी S इज इक्वल टू K इंटू S डैश रहेगा, क्योंकि यहाँ पे करेक्शन लगेगा, क्योंकि डेल्टा जो है दिस मच डिस्प्ले, ये B2 B डैश इसमें डिफ्लेक्शन होगा, ये C2 C डैश इसमें डिफ्लेक्शन होगा, डेल्टा। तो ये डेल्टा ये फ्रेम में डिफ्लेक्शन हो रहा है ड्यू टू दिस फोर्स S डैश फोर्स, द फ्रेम विल गेट डिफ्लेक्टेड लाइक दिस। तो ये डिस्प्लेसमेंट को कंसिडर करके यहाँ पे एंड मोमेंट डेवलप्ड होंगे इन द कॉलम मेंबर AB and in column member CD. No displacement in beam, so no moment will be developed in beam. Okay, so fixed end moment AB will be equal to fixed end moment BA होगा, and that will be equal to minus 6CR delta by L square. Okay, ये आपको पता है, if there is a displacement at any one end of the member, you can see the deflection, ये displacement, the moment is developed as anti-clockwise, that is 6CR delta by, and similarly fixed end moment DC and CD, that is minus 6CR delta by. तो ये fixed end moment we can find out. So here we have to assume the value of ER delta, because it is not given in the problem, that you have to assume it. Okay, you can assume it in any way, either you can assume the whole value of 6ER delta by square is 100 or 1000, or you can assume ER delta is equal to 100. Okay, that depends on you, because whatever the sway moments आपको जो मिलेगा वो assumed moment रहेगा, उसको K से मल्टीप्लाई कर दिया तो वो आपका करेक्टेड मोमेंट हो जाएगा, इसीलिए ऑलवेज करेक्शन इज टू बी अप्लाइड टू द स्वे मोमेंट. ओके, so that K factor can be different, okay, because if you see the various type of the books, okay, तो ये EI डेल्टा की वैल्यू एज्यूम अलग अलग वे से किया जाता है, तो K फैक्टर जो करेक्शन आपको मिलेगा वो डिफरेंट हो सकता है, लेकिन जो आपके फाइनल मोमेंट रहेंगे K फैक्टर भी अगर अलग है, क्योंकि स्वे मोमेंट्स भी अलग हो सकते हैं, लेकिन नॉन स्वे मोमेंट तो वही रहेंगे, क्योंकि यहाँ पे अपन एग्जैक्ट लोडिंग की वजह से मोमेंट कंसिडर कर, तो ये भी अगर अलग हुआ फिर भी आपका फाइनल मोमेंट सेम रहेगा. ओके, बिकॉज दिस इज अवर एज्यूम्ड वैल्यू, उसके अकॉर्डिंग आपका करेक्शन निकलेगा. ठीक है, इन अगेन ये आपको जो स्वे फोर्स निकालना है, अगेन यू हैव टू फाइंड आउट द रिएक्शन एट द सपोर्ट. ओके, HA2 HD2 वो अपन देखेंगे कैसे उसको कैलकुलेट करते हैं. ओके, तो वहां से आपको S डैश मिलेगा, फिर अपन K की वैल्यू निकालेंगे S बाय S डैश, और उसके बाद विल फाइंड आउट द फाइनल. ओके, सो दिस इज द वे हाउ वी आर गोइंग टू एनालाइज द sway frame using these 3 steps. Okay, so I think आपको ये समझ में आया होगा. ओके, ये जो भी मैंने यहाँ पे इक्वेशंस लिखे हैं, जो मैंने हाईलाइट किया है, ये पूरा विजिबल है. यस, दिख रहा है ना ये पूरा जो मैं लिख रही हूँ दोनों सेक्शन में. ठीक है, तो अभी जैसे जैसे अपन प्रॉब्लम्स लेंगे कल से, ठीक है, तो जैसे प्रॉब्लम अपन सॉल्व करेंगे, आपको अगर आप वो कॉपी में लिखते हो, सिर्फ आपको सुनना नहीं है, कैलकुलेटर लेके बैठना है, कॉपी लेके बैठना है, और साथ में मेरे साथ करना है यहाँ पर. ठीक है, सिर्फ देखने से कुछ नहीं होता. तो यहाँ पे एक मैं समराइज कर रही हूँ, अभी यहाँ पे मैंने स्टेप्स नहीं लिखे, तो अगर आपको स्टेप्स लिखना है, अगर आपके पास स्टेप्स है तो आप प्रॉब्लम को इजीली सॉल्व कर सकते हो। तो पहली स्टेप जो रहेगी, ओके, इसमें पहली स्टेप रहेगी ऑलवेज टू फाइंड आउट द फिक्स्ड एंड मोमेंट। ठीक है, ये पहला पार्ट रहेगा आपका नॉन स्वे एनालिसिस का। नॉन स्वे एनालिसिस, नॉन स्वे एनालिसिस में पहला पार्ट रहेगा नॉन स्वे, दूसरा पार्ट रहेगा स्वे एनालिसिस। ठीक है, तो नॉन स्वे एनालिसिस में पहले फिक्स्ड एंड मूवमेंट निकालेंगे। ओके, ओनली लोडिंग इफेक्टिव, मतलब लोड की वजह से जो फिक्स्ड एंड मूवमेंट है। सेकेंड स्टेप होती है डिस्ट्रीब्यूशन फैक्टर। थर्ड स्टेप रहेगा मोमेंट डिस्ट्रीब्यूशन टेबल। ओके, मोमेंट डिस्ट्रीब्यूशन टेबल, ये आपकी थर्ड स्टेप है। उसके बाद फोर्थ स्टेप रहेगी आपकी, फोर्थ स्टेप आपकी रहेगी, आपको नॉन स्वे फोर्स निकालना पड़ेगा। ओके, मोमेंट डिस्ट्रीब्यूशन टेबल में आपको नॉन स्वे मोमेंट मिल जाएगा, उसके बाद नॉन स्वे फोर्स। उसके बाद बी पार्ट जो रहेगा वो रहेगा आपका स्वे एनालिसिस। ओके, उस बी पार्ट जो रहेगा वो रहेगा आपका स्वे एनालिसिस। स्वे एनालिसिस में फिर से आपको फिक्स्ड मूवमेंट निकालने पड़ेंगे। फिक्स्ड मूवमेंट में डेल्टा की वजह से जो फिक्स्ड मूवमेंट मिल रहा है। सेकेंड आपका डिस्ट्रीब्यूशन फैक्टर तो ऑलरेडी कैलकुलेटेड किए हैं, वो वही रहेंगे। उसके बाद आपको स्वे मोमेंट डिस्ट्रीब्यूशन टेबल बनाना पड़ेगा, यहां से आपको स्वे मोमेंट्स मिलेंगे। ठीक है, उसके बाद थर्ड रहेगा आपको स्वे फोर्स निकालना पड़ेगा। ओके, स्वे फोर्स निकालने के लिए आपको इक्विलिब्रियम ऑफ द फ्रेम कंसिडर करके स्वे फोर्स, उसके बाद अपन मिलेंगे करेक्शन फैक्टर निकालना पड़ेगा s by s dash, and then we'll get the final moment. Okay, so these are the steps you have to follow, and accordingly you have to do the analysis. Okay, so is there any doubt? समझ में आया आपको? एटलीस्ट इसको कैसे, प्रोसेस को कैसे कैरी आउट किया जाता है, या फिर स्वे फ्रेम का एनालिसिस कैसे किया जाता है, इतना समझ में आया? फिगर से आपको आई थिंक समझ में आया होगा। ओके, सो एट द टाइम ऑफ सॉल्विंग द प्रॉब्लम्स जो भी आपके डाउट्स है वो क्लियर है, लेकिन आई वांट टू आस्क यू दैट वेदर यू गॉट द कंसेप्ट और नॉट। यहाँ पे दो एनालिसिस अपने को करना है, वो आपको ध्यान में रखना है। एक तो नॉन स्वे एनालिसिस और एक स्वे। दो मोमेंट डिस्ट्रीब्यूशन टेबल यहाँ पे बनेंगे, मतलब यहाँ पे इट विल रिक्वायर मोर टाइम कंपेयर टू द नॉन स्वे फ्रेम। ओके, सो ये फिगर से आई थिंक आपको समझ में आया होगा कि व्हाई वी आर डूइंग द सेपरेट एनालिसिस, बिकॉज लोडिंग एंड डिस्प्लेसमेंट इज नॉट considered simultaneously. Yes, if it is okay, then in the next class I will start the numericals on that. Please keep copy, pen and the calculators with you. Okay, इस साथ में आपको मोमेंट डिस्ट्रीब्यूशन करना है एंड आपको वैल्यूज भी क्रॉस चेक करना है, बिकॉज वॉट एवर आई एम एक्सप्लेनिंग हियर दैट इज ऑलरेडी देयर, वो पूरा यहाँ पे रहेगा। ठीक है, बट ट्राई एंड अंडरस्टैंड, और इट इज नॉट दैट मच डिफिकल्ट क्योंकि ऑलरेडी आपने ये मेथड पढ़ी हुई है। ठीक है, ओनली एक्स्ट्रा आपको एनालिसिस इसमें करना है। ठीक है, सो हियर आई विल स्टॉप। ओके, इसमें किसी को दोनों सेक्शन में ऐसा कुछ हुआ है कि आपको स्क्रीन विजिबल नहीं है या कुछ है फ्रॉम बोथ द सेक्शंस? आपको अगर कोई भी प्रॉब्लम फेस हो रहा है आप मुझे मैसेज कर सकते हो। एंड एवरीडे सेक्शन ए क्लासरूम लिंक से ज्वाइन होगा और सेक्शन बी जो मैं लिंक आपको भेजूंगी उसी से ज्वाइन होगा। ठीक है, अदरवाइज अटेंडेंस में डिफरेंस आएगा. Don't leave the meeting.